Bright Tuty. Every student matters.
This question, please try to relate. Two children are at opposite ends of an aluminium rod. One strikes the end of the rod with a stone. Find the ratio of times taken by the sound wave in air and in aluminium to reach the second child. Now, what exactly the question is saying? Please try to relate. The aluminium rod, let us take an aluminium rod. One child is here at one end, another child is here at the second end. Now, the first child hits the aluminium rod with a stone. We are required to calculate how much time will be taken by this sound to reach the second child in air. How much time will it take to reach the second child through this aluminium rod, and what is the ratio of these two times? Right? Have you understood the question? Good. First of all, try to relate what the question is. Now, we are required to calculate what? We are required to calculate the ratio of time. Fine. The speed of sound in air is taken to be what? 300. In air, the speed of sound varies. We'll take it to be 346 meter per second at average room temperature of 22 to 24 degree. Right? Now, the speed of sound in air is 346 meter per second, and the speed of sound, this was in air, the speed of sound in aluminium, it is 6420 meter per second. You don't have to actually learn these values. They will be provided to you in the question if some element or some metal like aluminium or iron is given. Okay. So, this from the table which is given in the book, we are just relating at the moment that the speed of sound in aluminium is 6420 meter per second. Now, we know that the formula for speed is equal to distance upon time. So, let it relate it like this, that the time is equal to distance upon speed. Fine. Now, for air, if we calculate the time T1, let the time T1 be the time taken by the sound to travel through air, that will be equal to distance S1 divided by speed V1. This we are talking about in air. When we talk about an aluminium rod, in that case, let the time taken be T2. The distance is the same. I'll take it to be S1 divided by the velocity will be V2 now. Right? We have to calculate the ratio. So, if I try to calculate the time taken in air will be equal to the distance S1 divided by the speed, that is 346, and the time taken in aluminium rod will be the distance keeping same S1, which we don't know. You can keep it X also or D also, right? And the velocity is 6420. Now, the answer that we are required to calculate is the ratio of times, that is T1 by T2. That means I am required to calculate T1 is S1 upon 346 divided by, I will put it like this, S1 divided by 6420. Multiplying it and exchanging the sides, S1 upon 346 multiplied by 6420 divided by S1. I can just strike off this S1 because both values are same. I am left with 6420 by 346. On calculating, you will get the answer to be 18.55. Right? So, the ratio of time taken in these two media is 18.55. Clear to all? Right? This is the required ratio. Fine? Alright. Let us see the next question. When a sound is reflected from a distant object, a far object, an echo is produced. Let the distance between the reflecting surface and the source of sound remaining the same. Do you hear the echo sound on a hotter day? Now, what type of question is this? Try to relate. He is saying that the sound is reflected from this distant object. Keeping the distance between these two same, will you hear the echo of the sound on a hotter day? We know that the speed is equal to distance upon time. Clear? So, from this formula we easily relate that speed and time, being in numerator and denominator, they are inversely proportional to each other, right. So, if time and speed are inversely proportional to each other, the only thing that is changing between a normal day or a cool day or a hotter day is temperature, and because of that temperature the speed of sound will vary, and as the speed of sound varies, the time also varies. So, on a hot day, being speed of sound directly proportional to temperature, on a hotter day the speed of sound will increase, and being inversely proportional, if the speed of sound is increasing, the time will decrease. So, we will hear the echo of course, and it will be in a lesser time, right. So, we will hear the echo, but the time taken will be different because the speed of sound will be different. Alright. Now, let us take next question. The next question says that a stone is dropped from the top of a tower 500 meter high. So, we are given the height or the distance of the tower to be 500 meter into a pond of water at the base of the tower. Now, because the stone is dropped, we have studied it earlier that if the stone is dropped, then in that case we will take the initial velocity represented by small u to be 0. Now, it is dropped in a pond of water at the base of the tower. Now, when is the splash heard at the top? We have to calculate when, that means we have to calculate the time. Given the value of g to us, that is 10 meter per second square, and the speed of sound is also given to us to be 340 meter per second. Now, first of all, the values which are given to me, on the basis of that I would try to calculate the time, and for time I will apply the second equation of motion, which says that S is equal to ut plus half a t square. S or the height is given to me to be 500 meter. So, putting the values, the initial velocity is 0, therefore, anything multiplied by 0 is 0, there is no point taking it. So, I am left with half into a is the acceleration due to gravity, which is given to be 10 to me, multiply by t square. So, I am left with, cutting up, I am left with 500 is equal to 5t square, or this gives me t square is equal to 500 upon 5 or 100. So, t will be square root of 100, which comes out to be 10 second. So, the time comes out to be 10 second. Now, this was the first part that I have done. So, in 10 seconds now the stone is reaching. The second thing I needed to calculate was what? When is the splash heard at the top? I need to calculate in 10 seconds the stone is reaching the pond, right. The time given taken by the stone is 10 seconds, but we need to calculate the speed of sound and the time taken by the sound to reach. Fine. So, we have to calculate not the time of the stone, but of the time of the sound of the splash. So, what I will do is I will simply apply the formula now, that speed is equal to distance upon time. So the stone takes 10 seconds to reach the pond. Now we also need to calculate what exactly will be the time taken by the sound to travel the same distance. And how I am going to calculate it? I am going to calculate it using the formula speed is equal to distance upon time. Now the speed is given to be 340 meter per second. Distance given is 500 meter. I will calculate the time. So time can be written as 500 upon 340, which comes out to be 1.47 second. So 10 seconds time was taken by the stone to be dropped and reaching the pond, and once the stone is dropped, it took 1.47 second for the sound to travel the same distance. Therefore, the total time after which we will hear the sound of the splash will be the 10 second taken by the stone to be dropped and 1.4 second taken by the sound. So I am able to hear the splash of the sound after 11.47 second. So this is all about our reflection of sound. I hope you have understood it all. Please try to relate. Thank you very much for watching.